Solving rational inequalities. A rational function for particular values of x can have one of these possibilities. When f of x equal to 0, that is where the top equal to 0. The function is undefined, where the denominator equal to 0. When we have those two cases out of the way, we can focus on where f of x greater than 0 or f of x less than 0. We determine this using the test point method. Let's look at one example. We try to solve this inequality. So first, let f of x be the function on the left-hand side. We will find the values where the function is equal to 0 and where the function is undefined. The function is equal to 0 when the top equal to 0 or the numerator equal to 0. X squared times x minus 2 equal to 0. So this is simple. We have x squared equal to 0 or x minus 2 equal to 0. X squared equal to 0 give us x equal to 0 and x minus 2 equal to 0 give us x equal to 2. Right. So that is where the function equal to 0. Where the function is undefined, the function is undefined when the denominator equal to 0. X plus 3 equal to 0. So x equal to negative 3. So what we have is these numbers x equal to 0, x equal to 2, and x equal to negative 3. We're going to put that on a number line or on the sign chart below. We're going to have x, negative 3, 0, and 2. We don't have to put them in the right scale, just need to be in the right order. We also have negative infinity here and infinity there. Right, here we have the function. Right, and also we have when x equal to negative 3, the function is undefined. X equal to 0, the function equal to 0. X equal to 2, the function equal to 0. Now we take care of the case where the function is equal to 0 and the function is undefined. Now we focus on the inequality where it's greater than or less than. For that, I using the test point. So the test point will be between each of those numbers. So I'll choose negative 4 here, negative 2, 1, and let's choose 3 here. I will use the calculator for that. So first, we have click y equal to and enter the function x squared times, we don't need to multiply, x squared times x minus 2. That's on the top. And then we divide by x plus 3 at the bottom. Just make sure we enter all the parentheses there. All right, now we just need the values. I will hit second trace, and the first one is the value. So I'll hit enter. It will grab the function. And now, ask what is x? If we enter -4 for x, notice -4, we have to use this negative sign and not that subtraction sign. So that's -4. We have 96. We only need to know if it is positive or negative. So it is positive. And then -2, we just need to enter -2. That is negative. And when x equal to 1, it is negative. And when x equal to 3, it is positive. Alright, so I have all the sign there and put the calculator away. Now we'll go back to our problem. Our problem, we have greater than or equal to, meaning that it's going to be equal to 0 or positive. It's going to be 0 or it's going to be positive. So on the sign chart, we're going to choose equal to 0 and positive. Equal to 0, we have this point, and equal to 0 also at x equal to 2. Right. The function is undefined at -3, so we cannot choose -3 ever. So it's going to be an empty circle there, regardless of the problem. The denominator cannot equal to 0. All right, then we also need to choose positive. It is positive in this interval. And positive in this interval. So with that, we can write the solution as -infinity to -3, but not including the -3. It can be 0, but we cannot just write the number 0 like this. We have to write a set of number 0. Or it could be from 2, including 2, to infinity. And we connect them with the union sign. And this is the solution to our inequality. One final note. We have this back in previous section. Even multiplicity, the graph will touch the x-axis and then turns around. So if we have the x-axis here and there is a 0, even multiplicity, it will touch and then turn around. Or it could be the other way. Regardless, it is either both of them will be on the top or both of them will be at the bottom. So what we have here is when we have an even multiplicity, the sign will not change when we're crossing a 0. When you go through the 0. For odd multiplicity, the function will cross the x-axis, so it will go like this. So one of them is above and one of them is below. So we will have, when an odd multiplicity, the sign will change when passing a 0. So that depends on the multiplicity. Now go back to our problem. In our problem, we have x equal to 0 is this is an even multiplicity because of the 2 here. X equal to 2, this is odd multiplicity, and x equal to negative 3 is also an odd multiplicity. And we'll just take a look at the sign chart. It will go from positive to negative because this is an odd multiplicity, so the sign will change. This is also 2, it's also an odd multiplicity, so the sign will change from negative to positive. When x equal to 0, that is an even. The sign do not change, so the negatives stay negative. So that's just a little note I want to mention. Thank you for watching.